Hi students, once again I welcome you all to my channel Abrar Sir classes. Today we'll be seeing some important problems on the topic moment of inertia of point masses, which comes in the chapter rotational motion. This is the first problem. It is saying moment of inertia of point masses about given axis as shown will be. You are supposed to calculate moment of inertia of point masses. These are the two point masses they have given, and you are supposed to find the moment of inertia of point masses about given axis as shown. Okay. Now, what is the formula for moment of inertia for a point mass? We know that I is equal to what? M r square, right, for a single mass. Then what is m? M is nothing but mass of body. Mass of body. What is r? R is nothing but perpendicular distance. Perpendicular distance of mass from AOR. What is AOR? Axis of rotation. Axis of rotation. Axis of rotation. This is for a single mass. If we have system of masses, I can write that as I system. Okay. If we have more than one masses, okay, that is given by m r square, m I r I the whole square, where I is equal to 1 to n. If there are n masses, okay, I have to write moment of inertia of the system is given by summation of I is equal to 1 to n, m I r I the whole square. If it, for three mass system, let us say for two mass system, okay, for two mass system, what I can write? I can write I, okay, is given by what? M1 R1 square plus M2 R2 square, right? In turn, I can write what? I system is equal to what? I system is equal to I is equal to what? 1 to 2 Mi Ri the whole square, right? Okay. If I expand this summation, I'm going to get what? M1 R1 square plus M2 R2 square. How much is M1? M1 is equal to what? 1 kg. How much is M2? M2 is equal to 1 kg. Now what is R1? R1 is nothing but what? Perpendicular distance of mass from axis of rotation. This is axis of rotation. This is axis of rotation. So this is at a distance of what? This is R1. R1 is how much? R1 is equal to 2 meter, and from this one, okay, axis of rotation, R2 is equal to how much? 2 plus 2, that is equal to 4 meter. Hope you understood this one. You are supposed to calculate perpendicular distance of mass from axis of rotation. Here it is at a 2 meter distance. R1 is equal to 2 meter. R2 is equal to 2 plus 2 is how much? This 1 kg of mass M2 is at 4 meter distance. Therefore, just expand this one. M1 is how much? M1 is 1. Okay, 1 into R1 is how much? 2 the whole square plus of M2 is how much? 1. R2 is how much? 4 the whole square. That is equal to 1 into 4 plus 1 into 16. 4 plus 16, that is equal to 20. What is the unit of moment of inertia? Kg meter square. Okay, unit is what? Unit is what? Kg meter square. What is unit of mass in a system? That is unit is what? Is equal to kg. Square of the distance means meter square. Kg meter square. Hope you have understood. Okay, from axis of rotation. Okay, from axis of rotation. Okay, is given by how much? 20 kg meter square. This is the right answer. Hope you understood this. Okay, kindly remember this formula. For a single mass system, I is equal to mr square, unit is kg meter square. For a system of masses, okay, I system is equal to summation of I is equal to what? N mi ri whole square. Hope you understood this. Next problem, I can do a little bit fast so that you are familiar with the formula. Now, calculate moment of inertia with respect to rotation axis. This is the axis of rotation. Okay, axis of rotation xx dash. Okay, in following figures, figure a. Now where is this is, I will call this as m1. Okay, m1 is equal to how many kgs? 1 kg. m2 is equal to how many kgs? 4 kg. m1 is at a distance of how much? This is, see, this is 0. Okay, this is 0 centimeter to what? 100 centimeter. This is a distance of 20 centimeter. Therefore, from axis of rotation, it should be how much? From axis of rotation, r1 is equal to how many centimeter? 100 minus 20 is 80 centimeter. Right, 80 centimeter. This is m2. Okay, and m2 is at a distance of how much? This is 100 minus 70 means 30 centimeter. r2 here, r2 is equal to how much? r2 is equal to 30 centimeter. See, I told you what is unit of moment of inertia? Kg meter square. Okay, here mass is given in kg. Okay, but you have to convert this into what? Centimeter to meter. Centimeter to meter you have to convert here. Okay, that is equal to r1 is equal to how much? 0.8 meter I can write. r2 is equal to how much? 0.3 meter. Okay, now use the formula I x dash. Okay, that is equal to m1 is how much? 1 into 0.8 the whole square plus of how much is m2. I'm writing directly. Okay, m1 into r1 the whole square plus m2 into r2 is the whole square. Hope you understood. Okay, that is equal to, now expand this one. What is 0.8 into 0.8? That is 0.64, right? And this is plus 4 into 0.3 into 0.3 is how much? 0.09. Okay, that is equal to 0.64 plus a 0.36. That is equal to how much? 1 kg. 1 kg meter square. Hope you have understood this. Okay, for figure A. Now for figure B. For figure B, okay, xx dash where here is here, horizontal. Okay, how many masses are there? 1, 2, 3 masses are there. Okay, let me call this as m1. Okay, this is what? m2. This is what? m3. Okay, 3 mass system. This is, okay, use the formula I x dash. This is axis of rotation. This is axis of rotation. m1 is how much? m1 is 4. So it is at a distance of how much? Okay, 3. Okay, let us say this is kg. This is what? In meter. Okay, meter. Let us assume meter. Okay, now this is at a distance of how much? From x-axis, from x dash, xo x dash o 3 the whole square plus of, there is m2 is here, 2 into, again the distance of this one. This is magnitude you have to take. Okay, this is how many? 2 meter, right? 2 meter. This is at the distance of 3 meter, right? This is 2 meter. That is 2 the whole square, right? Plus of m3 is 3 and how much? This is 4 meter. This is the distance of 4 meter. 4 the whole square. That is equal to 4 into 9 plus of 2 into 4 plus 3 into 16. 3 into 16. 4 9s are 36. 4 2s are 8 plus 46 into 3 is 48. That is equal to 36 plus 8 plus 48. That is going to be 90 kg meter square. This is for figure B. Answer for figure A is, we got 1 kg meter square, and for figure B we got how much? 90 kg meter. Hope you understood. Okay, let us do the next sum. What is saying? 3 particles each of mass m, okay, are situated at the vertices of an equilateral triangle ABC. This is equilateral triangle. Okay, all sides are equilateral triangle. L is given. Okay, as shown in the figure, right? Okay, what is the distance? L. Okay, of side L. Each side is what? From A to C is L, C to B is L, and A to B is also L. Equilateral triangle. The moment of inertia of the system about a line AX. Okay, this is line AX IAX is equal to how much? Now there is a mass here. Okay, there is a mass here, there is a mass here, there is a mass here. There will be no contribution of this m. Okay, there will be no contribution of this mass. Okay, now okay, there is no contribution. There is no contribution of this mass because it is lying on the same line. Contribution, there is no contribution of this mass. This mass as it is lying on the same axis. Understood? Okay. What is the distance? Distance is 0. Okay, there is no contribution of this mass as it is lying on the same axis. So which is the other mass here at a distance of how much? L square. Okay, L square. Okay, what is the distance from this one? Perpendicular distance is C. Perpendicular distance from A to C is how much? L plus of, and what is perpendicular distance from A to B again? L square. Okay, you have to assume like this. I will make you understand very clear. I can write the horizontal figure for the same thing. Let us assume this is A, this is C, and this is B. Okay, you have to assume that this axis is what? Okay, let us say this is there in the horizontal plane. The axis is like this. The axis is passing through like this. Okay, here mass m is there, mass m is there, mass. Okay, this is lying on the horizontal plane, and this axis is like this. Okay, there is no contribution of this one. Okay, this mass. Okay, now what is the perpendicular distance? Is L. Perpendicular distance of this mass is L. So ml square plus ml square, how much? 2 ml square is the right answer. Hope you understood this one. 2 ml square is the right answer. Let us do the next sum. What is this? 4 point masses each of value m are placed at the corners of a square. Okay, A, B, C, D is a square. Okay, this is A, B, C, D is a square. Of side L. Okay, the moment of inertia of this system about an axis passing through A. Okay, passing through A and parallel to BD. Where is BD? BD is here, right? BD is here. Parallel to BD means the moment of inertia of the system of an axis passing through A and parallel to BD. Passing through A and parallel to BD is like this. Okay, this axis. Okay, this axis. Okay, this axis. What is C? Let us say there is some mass m here. Okay, mass m is kept here. Okay, mass m, some value in general m I have taken because we have given value m. Okay. Is there any contribution of this mass? No. No contribution. Okay, of this mass. Now, this is axis of rotation. This is axis of rotation. This is axis of rotation. You have to calculate what? Moment of inertia of this system about an axis passing through A and parallel to this. Okay, A axis. A O R. Okay. Now which is the first one? Okay, mass. This is m. This is m, and this is m. Okay, this is parallel to what? B and D. Right. Now, what is the perpendicular distance from this mass kept at C? If this is L and this is L, what will be the value of this one? You know very clearly. Okay. If this is L, this is L. By using Pythagoras theorem, you will get what? Root of L. Okay. Root of L is the perpendicular distance. Okay. Root of 2L is the perpendicular distance. Okay. Root of 2L is the perpendicular distance. Now, what about this one? What about this particular thing? What is the perpendicular distance of this mass to this axis of rotation and this mass to the axis of rotation? One is what? AC. Okay, AC. AC is how much? Root of 2L. If this is L, if this is L, by using Pythagoras theorem, you are going to get this as root of 2L, right? Root of 2L. What about this one and what about this one? This will be half of this one. Half of this one, see here. Okay. This is root of 2L. This AC is how much? AC is how much? AC is equal to root of 2L. If I take this as, let us say, if this is some point, let us say P, some point Q. Okay. What will be dq? dp will be equal to how much? bq. Okay, bq, and that will be equal to how much? Root of 2l by 2. Okay? Half of this one. Okay, exactly. That is equal to how much? Root 2l by root 2 into root 2. We are going to get l by root. L by root. So there will be contribution of 3 masses. Okay, since this mass is lying on the axis of rotation, there is no contribution to find out the moment of inertia. Only contribution because of this mass kept at d. Okay, which is the distance. How much? Distance is how much? L by root of 2, and one more mass that is kept at b at a distance, perpendicular distance, L by root of 2, and one more mass which is kept at c. Okay, which is the resistance root 2 L. Therefore, m, okay, let me take mass kept at m, L by root 2 the whole square, right, plus this m, L by root 2 the whole square, plus of this one. Okay, the mass kept at c, m into root 2 L the whole square. That is given by, that is equal to m L square by 2 plus of m L square by 2 is, if you square this, L by root 2 L square by 2 plus of, if I square this, how much it is going to get? Okay, m, okay, 2 L square, 2 L square. This will be 2 L square. Now add up this one. This is 2m L square plus of m by 2 L square, m by 2 m L square. That is equal to 3m L square is the right answer. Hope you understood this. Okay. Next problem we will see. Now, again this problem, they are asking how many masses are there? 1, 2, 3, 4 masses are kept here. Okay. And you are supposed to calculate the moment of inertia of the system of bodies about x-axis. Okay, Ix is equal to Ix axis. Okay, x-axis. The masses which are kept on the x-axis will not be there. Okay, only the masses which are either side. This is okay. 3 at a distance how much? 3 the whole square, right? Plus of one more mass is there here. Plus of 4 into at a distance of how much from the x-axis? 2 the whole square. Hope you understood. 3 into 9 plus 4 into 8. Right. So 3 into 8, it is 4, 3 9s are 27, please, plus 4 into, this is 4 into 4, right? 4 into 4, right? 27 plus, be careful while multiplying. 27 plus 16 is how much? 43. Okay, I can take this as meter, okay, meter, all meters only. I can write 43 kg meter square. Hope you understood. Iy is equal to what? Where is Iy? Y is this one. Okay, so the contribution of this one will not be there here. Contribution of this one will not be there. Only this, okay, only this and this mass will be there. So here 2 at a distance how much? At a distance of 2 the whole square plus of one more mass. Okay, it is kept at a distance of 2 meter. So 4 into 2 the whole square. Hope you understood this. When you consider x-axis, okay, these two masses are going to come, 3 and 4 that I have written here. 3 at a distance of 3 distance the whole square plus 4 into distance, okay, that is 2. Magnitude you should take. And then when you consider y-axis, this is y-axis, this is what? X-axis, right? This is x-axis, and this is what? y-axis, right? For y-axis. So this will contribution, this will not be there, this will not be there. Only 2, that is 2 at a distance of how much? 2 the whole square plus 4, okay, at a distance of, that is 2 into 4 plus 4 into 4. How much is this? 8 plus 16 is equal to 24 kg meter square. Hope you understood this. Iz, for Iz, where is Iz? Okay, you have to assume Z is what? Into the plane of the paper, into the plane of the board. Okay, you have to consider like this. Okay, either it is coming outside the plane of the board or going inside the plane of the board. At that time, you should consider the contribution of how many masses? 3 masses. 5 kg will not be there. Okay. This, when you consider this one at a distance of how much it is? 2 the whole square, right? When you consider this mass which is lying on the top, 3 at a distance of how much? 3 the whole square, right? When I consider this one, this, what is the perpendicular distance? Perpendicular distance will be this one. Perpendicular distance will be this one. See, this is from the y-axis 2 meter. From the x-axis it is how much? 2 meter. This is 2 meter, this is 2 meter. How much this will be? This will be 2 root 2. 2 root 2 meter. Perpendicular distance will be how much? 2 root 2 meter. 4 into 2 root 2 the whole square. Be careful while calculating the perpendicular distance from the z-axis. Okay, this is from the y-axis it is 2 meter. From the x-axis it is 2 meter, right? This will be how much? Use Pythagoras theorem. The square of the hypotenuse is equal to sum of the squares on the other two sides. It will be 2 root 2. That is equal to 2 into 4 plus 3 into 9 plus 4 into 4 into 2. 8. Okay, 16 into 2, 32. That is equal to 8 plus of 27 plus 32. That is equal to how much? 40, 67. 67 kg meter square. Hope you understood for z axis. Okay. Now, next problem we'll see. And this is the last problem for today's class. Now, you have to calculate again the amount of inertia in an arrangement. 4 particles, each of mass 2 gram is given. Okay, are situated at the coordinate points. Okay, let's see. If gram is given, okay, gram is given, we'll take centimeter. If kg is given, we'll write meter. Okay. Otherwise, in general, whatever they have given units, you can write after calculating amount of inertia. Okay. Now, the moment of inertia of this arrangement about z-axis. What is the formula? Whenever you consider z-axis, what will be there? Only you should consider what? x1 square plus y1 square. No contribution of z will be there here. Plus similarly, plus m2 into x2 square plus of y2 square. Hope you understood this one. Plus m3, how many masses? 4 masses are there. Okay, okay, each of mass 2 gram. m3 into x3 the whole square plus y3 the whole square plus m4 x4 the whole square plus of y4 the whole square. Okay, let me consider this is what? x1 y1 z1. Okay, x2 y2. This I will consider what? x1 y1 z1. This is x2 y2 z2. No need to write, directly you can substitute. How much is m1? Directly I'll write 2. Okay, how much is x1? x1 is 3 the whole square plus of y1 is 2 square plus of m2 is again 2. x2 is how much? 1 square plus of y2 is how much? Again 1 square I will write. Okay, plus of m3 is 2, 0 here. Okay, no contribution, plus of, because everything is 0, it is lying on the what? Origin. Plus of m4 2 into what? 1 the square, actually minus 1 the whole square plus of what? 1 the whole square. And here also, in the second case, 2 into 1 the whole square plus of minus of 1 the whole square. Now we will just calculate 2 into 9 plus of 4 plus of 2 into 1 plus 1 plus 0 plus 2 into 1 plus 1 is 2. That is equal to how much we are getting? 1326 plus 4 plus of 4. So 8 plus 26 is 34. Okay, 34. You can write gram centimeter square, or in general they have given 34 units. Okay, in general we do not know whether it is given in centimeter or meters. Therefore, in general, write 34 units is the right answer. Students, hope you understood this lecture to find moment of inertia of different system of masses. If you like this video, kindly share with your friends, ask doubts in the comment box, and subscribe for my channel. Like it if you really liked it. I wish you all the best for your KCET, NEET, and IIT JEE main and advanced examinations. Keep studying, get motivated. I wish you all the best. God bless you all. Thank you for watching my video.